let's talk about scenes in Unity. Scenes are great. We can very quickly sketch some level, add some simple behavior or effects, and immediately show them to a potential audience or at least test it ourselves. Most of the stuff we do for a typical Unity project will sooner or later end up in some scene. So in a way, they are a central hub which contains most of our work. This is great for quick prototyping and reaching first results. From a version control point of view, it's not exactly great. I hope you will understand what I mean after the next couple of videos. We once again have a new Unity project, and this time I want to interact with a scene. My first important recommendation when you want to work on scenes on different branches is that you immediately check in the default scene before you start creating branches. If you don't, Plastic will treat the default scene on the different branches as totally different scenes, and you will have an even harder time merging them. There are two ways to add the default scene to Plastic. We can either go to the scene asset and choose Add to Source Control, or you can make some minor change to the scene, after which Plastic will detect the change automatically. I want to add a plane first anyways, so I choose the second option. Now I will create a branch on which I will make some change to the scene. Let's add a blue cube. After that, I will go to the main branch and make a different change. How about we add a red cube? And now to the interesting part. I want to merge the different changes together. By now we know how to do that. When I get to the merge window, this time I see a red notice. We have our first merge conflict. As you can see, there is no issue with the added material files, because those are just separate files which can simply be both added to the merged version. A conflict happens when different branches touch the same file. In our case, we made changes to the scene file on both branches. Now, with the red color, this all seems pretty dramatic. But Plastic by default can automatically solve a lot of those cases. For now, all we have to do is to press the Resolve Conflicts button, and the merge is completed. What do you think happened in Unity with the automatic resolution? Let's check. When we reload, we can see that both cubes are added to the scene. What's more, Plastic is smart enough to add the cubes to the hierarchy correctly under the plane object. So essentially, as long as there are no contradictions, an automatic resolution will just add both versions during the merge. In a case like we have here, where the changes were clearly isolated on different game objects, this might work just fine. But let's now see a different example where the automated resolution might introduce some problems. For that, I will first add a new game object, this time a sphere. Now I will branch off again. On this branch, I will give the sphere some blue material. Then again, I will switch to main, and here I will give the sphere a red material. You might already see an issue. What should the color of the merged version be? A reasonable thought at this moment would be that we will have to manually interfere since the changes are contradicting. But when we go to the merge window and try to resolve the conflict, we have no issue and the merge is done. Let's go back to Unity and check what happened. Okay, that's weird, right? We only have one sphere and it's blue. Why did plastic choose to make it blue? When we inspect the sphere game object, we can see the answer. For plastic, this was no real contradiction. From a purely technical point of view, the materials here are just an array, and so it added both. What Unity then does is just display the first material, which is totally arbitrary. So maybe we are lucky and this is what we actually wanted, but chances are that the automatic solution is not providing the result we expected. Obviously, this was a minimalistic example, but imagine someone working on several game objects with several components. If you are not careful, an automatic resolution might add a lot of unintended side effects. For now, let's just take away that in some cases, an automated resolution might be what we want, especially when we have a very disciplined and isolated way to work, but in other cases it might not work at all. There is, however, a third category of changes which I will show you now. For that, I will simply add a rigid body to the sphere game object. And this time on the variation branch, I will increase the mass value on the rigid body to 4. And back on the main branch, I will change the value to 2. When we try to merge, at first glance, everything looks the same. Let's first have a quick look at the merge diagram because it will help us in a second. I told you that typically we need 3 elements for a merge: the base, the source, and the destination. In this example, it's nice and clear what each of those are. The base is the change set from which we branched off. This was after we added the rigid body to the scene. The source is the change set on which we manipulated the mass value on the new branch. And the destination is the change set with the mass value on main. When we go back and press Resolve Conflict, Plastic cannot solve this on its own anymore, because the values are contradicting each other. We get a new window, which is Plastic's merge tool. And now it's useful to know the terms base, source, and destination, because those kind of merges will always have the same structure. This is also called a three-way merge. On the left, we have the changes introduced by the source change set, where we set the value to 4. In the middle is the base, which represents the conflicting value at the moment when we branched off. This was the default value on a rigid body, which is 1. And on the right, finally, we have the version of the destination change set from main with a value of 2. The bottom half of the screen is showing the current result of our merge. As long as you see some red hints, there is a conflict which we have to solve. To solve the conflict, we can decide which changes we want to keep. In our case, I want the value to be 4, so I deselect the values from the base and the destination and just keep the value from the source. When I do that, red turns into green, which is indicating that this is an acceptable version without a conflict. Obviously, acceptable from a technical point of view. I have to understand the logical implications for the game myself. In this case, what it means to have a heavier mass. Plastic cannot help me with that. Finally, I can choose Save and Exit. And voila, we resolved our first conflict manually. When we go to Unity, we can see that indeed the value on the rigid body is now set to 4. So let's quickly recap what we did through the last few minutes. We saw 3 versions for a conflict resolution in plastic. By default, plastic will always try to resolve conflicts automatically. In the first example, we saw that this can actually work quite well in certain scenarios. In the second example, however, we saw that automatic merging can introduce unexpected states or introduce side effects which we might not like. The third and final example showed a case where an automatic resolution was not possible at all and we had to manually interfere. So, which version should you choose? You probably guessed it. This is highly dependable on your use case. For some projects, automatic resolution might work just fine. For other, rather bigger projects with many collaborators, it might cause a lot of mayhem. If you have a project where it's difficult to clearly isolate portions of your work, you can also completely disable automatic merging, and that is what we will look into next.